Hi, this is Miss Holly, and here I'm going to go over the solutions to the Grade 4 Mathematics EOG released form. Okay, starting on question number 1, there are 594 children participating in a county science fair. They are put into groups of 6 children. How many groups will participate? Okay, so we have 594 children, and we're splitting them up into groups of 6 kids each. That means that we're going to want to divide 594 by 6. So 6 doesn't go into 5, 6 goes into 59. Let's see, 9 times, that was hard to see. 9 times 6 is 54. 59 minus 54 is 5. And we're going to bring down that 4. And 6 goes into 54 9 times, which means our answer is going to be 99. And we could always do the 9 times 6 is 54. Subtract that out. You get 0, just to finish up the problem. Okay, which figure has at least one acute angle, one obtuse angle, and one right angle? So if we remember what an acute angle is, an acute angle is any angle that's less than 90 degrees. And a 90-degree angle looks like this. That's a right angle. An obtuse angle is an angle that's larger than 90 degrees. So that's normally going to look like this. So we're looking for one of these that has an acute angle, an obtuse angle, and a right angle. If we look at A, this angle here looks like it could be a right angle. This angle is acute. This angle is also acute. So that's not going to work out. If we look at figure 2, this looks like an acute angle. This one's obtuse. This is acute. That's obtuse. It's not going to work out because we don't have a right angle. Figure C, all of these angles are the same, which means they definitely can't be an acute, a right, and an obtuse angle in here because all these angles are going to be the same type. For figure D, here we have a right angle. Here, this angle is clearly more than 90 degrees, so that's obtuse. This angle is smaller than 90 degrees, so that's acute, which means we have at least one of each. So figure D is going to be our solution. Number 3. Each day of the work week, Mr. Harbin uses 3/4 of a gallon of gas. Which estimate best describes the amount of gas Mr. Harbin would use in a 5-day work week? Okay, so he's using 3/4 every day for 5 days. So if we consider this problem, he's using, okay, so 5 times 3 is 15. So this is equal to 15/4. Now 15/4 is going to be, if we simplify it out, 4 goes into 15 3 times. So if we put this as a mixed number, we're going to get 3 and 3/4. And so that's going to be C, between 3 and 4 gallons. Okay. The body and head of a fox measure 19 4/5 inches, and its tail measures 10 4/5 inches. What is the total length of the fox? Well, to get the total length of the fox, we're going to want to add the length of the body and head to the length of the tail. So 19 4/5 plus 10 and 4/5. So 19 plus 10 gives us 29. 4/5 plus 4/5 equals 8/5. And if we write 8/5 as a mixed number, 5 goes into 8 one time, and then there's 3 left over, so we get 1 3/5. So we can turn this problem into 19 plus 10 plus 4/5 plus 4/5, which means it's equal to 29 plus 1 3/5. And that's just going to be 30 3/5. Now, the other way you could possibly do this is by multiplying everything out so that we get all so that we get all improper fractions instead of mixed numbers, and then simplify. So we could turn 19 4/5 into, let's see, 50, 95, 99/5 by multiplying 19 by 5 and then adding 4. And then we would add that to 10 4/5. 10 times 5 is 50. 50 plus 4 is 54. So that's 54/5. And altogether, we would get 153 over 5. 5 goes into 153 30 times, and then we'd end up with 30 3/5. So same solution either way. Number 5. There are 136 students in the school cafeteria. There are 8 students sitting at each table. How many tables are in the cafeteria? All right, so there's 136 students. Each table has 8 students. That means that to find the number of tables, we need to divide. We're going to do, let me write this down here so we have more space. 136 divided by 8. 8 goes into 13 one time. 1 times 8 is 8. 13 minus 8 is 5. Bring down this 6. 8 goes into 56 7 times, and we get 17. So 17 tables. Which list contains exactly 2 prime numbers and 2 composite numbers? So here what we need to know is the definition of a prime number. A prime number is a number that has no factors, which means that there are no numbers that go into that number evenly. For example, 3 is a prime number because there aren't any other numbers that you can multiply together to get to 3 other than 3 and 1. If we look at these solutions, before we look at the solutions, a composite number is the opposite of a prime number. So for example, a composite number might be 4 because 4 can be written as 2 times 2. So for a prime number, it can only be written out as itself times 1, and there's no other number that you can divide evenly into it. So looking at these answers, 13 is a prime number because it has no factors or no numbers that go into it. So that's prime. 14 is composite because 2 and 7 go into it, so that's going to be a C. 15 is composite because you can write 15 as 3 times 5. 16 is also composite because 16 can be written as 4 times 4 or 8 times 2. So here we have 1 prime number, 3 composites, so that can't be our solution. For B, 2 is actually a prime number because you can only write 2 as 1 times 2. There's no other number that goes into 2. So 2 is prime. 4 can be written as 2 times 2, so it's composite. 5 is prime, has no factors. 6 can be written as 2 times 3, so that's composite. That means that B is our solution because there's 2 primes and 2 composites. Number 7, a cafeteria manager ordered 1,251 cartons of milk on Monday. He also ordered cartons of milk on Thursday. He ordered 879 more cartons on Monday than on Thursday. How many cartons did the manager order on Thursday? Okay, so we know that he ordered more cartons on Monday than on Thursday. That means he must have ordered less cartons on Thursday. So since we know the number he ordered on Monday, we need to subtract from that to get the number from Thursday. So we're going to do 1,251 minus 879. And when we do this, we're going to do, we can't subtract 9 from 1, so this 5 becomes a 4, becomes an 11. 11 minus 9 is 2. Can't subtract 7 from 4, so we borrow from this 2. That becomes a 1. 14 minus 7 is 7. Can't do 1 minus 8, so you take from this 1, that becomes a 0. This becomes an 11. 11 minus 8 is 3. So our answer is just 372. Dana ran on Monday and Tuesday. She ran 5 2/10 kilometers on Monday. She ran 4 6/100 kilometers on Tuesday. How far did Dana run altogether? Okay, so to do this, we want to get these two numbers to have the same common denominator. Now to get 5 2/10 and 4 6/100 to have the same denominator, the smallest number that both 10 and 100 go into evenly is 100. So we don't need to change 6/100 at all. But 10 goes into 100 10 times. So we're going to multiply this 2 over 10 by 10 over 10. And that's going to give us 20 over 100. So now we're going to do 5 and 20 over 100 plus 4 and 6/100. 5 plus 4 is 9. 20 plus 6 is 26. So this is 9 and 26 over 100. What fraction is shaded in each of these models? Okay, so if we look at model 1, we have 1, 2, 3, 4, so on 5, 6, 7, 8, 9, 10, 11, 12 boxes total. And of those 12, 8 are filled in. In the second figure, we have 1, 2, 3, 4, 5, 6 boxes, and 4 are filled in. Now, To do this problem, we need to know how to simplify fractions. To simplify a fraction, we're going to want to find the biggest number that goes into both the top and the bottom. So we know that 2 goes into both 4 and 6. So we can divide this by 2 over 2, or divide the top by 2, divide the bottom by 2, and we get 2 over 3, because 2 times 2 is 4, 2 times 3 is 6. So when we simplify these fractions, we're going to get 2/3. And if we did the same thing with 8/12, the biggest number that goes into both 8 and 12 is 4. So we're going to do 8 divided by 4 over 12 divided by 4 equals 2 over 3. So both of these fractions equal 2/3. Number 10. A group of friends were each completing a project of the same size. This table shows how much of the project each friend has completed. Which friends have completed an equal amount of their project? Okay, so we want to know which friends have completed an equal amount of their project. That means that they've completed the same amount. So we're looking for which of these two fractions is equal. So to do that, we're going to want to get the fractions to have common denominators. Our first fraction is 2/3, then 1/2, 6/8, and 4/6. Now, if we simplify 6/8, we can turn that into divided by 2, divided by 2. Well, we can turn this into 3/4. And I'm just going in and doing that because the first step we should do before we try to find a common denominator for everything is to go ahead and simplify the fractions as much as we can ahead of time. So 4/6 divide by 2, divide by 2, and we get 2/3. And we can't simplify this 2/3 or this 1/2 at all. But what we're going to notice here is that when we simplified 4/6, we got 2/3, which is the same as 2/3 up here. So it was Michael who had 2/3 originally and Sumi who had 4/6. So our answers are going to be Michael and Sumi. Pablo is getting ready for a bike race. He rode his bike each day for 32 days. He rode his bike for 45 minutes each day. How many minutes did Pablo spend riding his bike to get ready for the race? Okay, so he rode his bike for 32 days, 45 minutes each day. That means we want to do 32 times 45. Now to do 32 times 45, we're going to set it up like this. 5 times 2 is 10, 0, carry the 1. 5 times 3 is 15, plus 1 is 16. Bring a 0 down. 4 times 2 is 8. 4 times 3 is 12. And if we add that all together, we get 0, 6 plus 8, 4, carry a 1. 2 plus 1 is 3, plus 1 is 4. And then bring this 1 down. So 1,440 is going to be our solution. There are twice as many women on a bus as there are men. There are 24 women on the bus. What is the total number of men and women on the bus? Okay, So we know that there are twice as many women on the bus as there are men. That means there are less men on the bus than women. So to find out how many men were on the bus, we need to divide. 24 divided by 2. And that's going to be 12. So now we know that there were 24 women and 12 men. To find the total number of men and women on the bus, we're going to need to do 24 plus 12. And that's going to get us 36. Okay. Patrick made 12 cookies. Patrick's sister will eat 4 of the cookies. What fraction of the cookies will be left? So if we look here, they've split the cookies up into 3 groups of 4. If Patrick's sister eats 4 of the cookies, she's eating one of these groups. That means that out of the 3 initial groups, she's eaten 1. What's remaining, this part, is 2 out of the 3 initial groups. So the leftover part is, 2/3. And it's important to note here that they ask what fraction of the cookies will be left, not what fraction did she eat. Each classroom at a school has 24 desks. There are 18 classrooms in the school. How many desks are at the school? Okay, each classroom has 24 desks, and we're going to want to multiply that number of desks by the number of classrooms. 24 times 18. 8 times 4 is 32. Carry the 3. 8 times 2 is 16, plus 3, 19. Put a 0 here. 1 times 4 is 4. 1 times 2 is 2. 2 plus 0 is 2. 9 plus 4 is 13. Put down a 3. Carry the 1. 2 plus 1 is 3. 3 plus 1 is 4. And we get 432 desks. 4 friends each ate 2/3 of an apple. How many apples did the 4 friends eat in all? So if each friend ate 2/3, we want to multiply 2/3 by 4. And remember that we can write 4 as 4/1. So if we do 4/1 times 2/3, 2 times 4 is 8. 3 times 1 is 3, so we get 8/3. Now, 3 goes into 8 2 times, so we can rewrite this as 2, and then 2 times 3 is 6. We still have 2 left to get to 8, so this is going to be 2 and 2/3. Answer D. 16. A farmer has an equal number of cows in 3 different fields on his farm. Which choice could be the total number of cows? So if he has an equal number of cows in each of these fields, that means that each of these fields needs to have a whole number of cows, right? Because we can't have part of a cow. So the total number of cows he has to be divisible by 3. So if we divide that total by 3, we should get some number of cows that doesn't have a fraction or anything. Because once again, we don't have part of a cow in a field. So if we do 112 divided by 3, we would get 3. 3 times 3 is 9. Subtract that from 11. 2. Bring down this 2. 3 goes into 22 7 times. 7 times 3 is 21. So we would get 37 remainder 1. So since we have that remainder, that means that we wouldn't have the same number of cows in every field, so it can't be A. If we do the same thing for B, we're going to again get a remainder. So our solution can't be B. If we do it for C, let's see, 3 into 207. 3 goes into 20 6 times. 6 times 3 is 18. 20 minus 18 is 2. Bring down that 7. 3 goes into 27 9 times. 9 times 3 is 27. Subtract that, and we get 0, so there's no remainder here. 3 goes into 207 exactly 69 times. That means that C is our answer. There are 128 pencils to be put into boxes. Each box can hold 9 pencils. How many boxes can be completely filled? So, an important thing to note here before we do the problem is that they say completely filled. That means that we want to know how many boxes we can put 9 pencils into, not a box with 6 pencils or 5 pencils or anything left over. So to figure out how many boxes, we're going to want to divide 128 by 9. Nine goes into 12 one time. 1 times 9 is 9. 12 minus 9 is 3. Bring down the 8. 9 goes into 38 4 times. 4 times 9 is 36. Subtract that, and we get 2. So our answer is 14, remainder 2. So that means that we can fill up 14 boxes, and then we'll have 2 pencils left over. So our answer is going to be 14. And the reason it's not 15, even though those 2 pencils could go into another box, is that that box wouldn't be completely full. Okay. Which 2 of these squares have the same amount shaded? Let me just erase this right here. All right. So we want to figure out which squares are equally full. So which of these fractions is the same as another one? So if we look at P, this box is split into 4 triangles, and of them 2 are shaded. That means that this fraction stands for 2/4. In box Q, we have 1, 2, 3, 4, 5, 6, 7, 8 pieces, and 3 are shaded, so this box is 3/8 full. In R, we have 4 triangles, and 3 are shaded, so it's 3/4. And in S, we have 8 triangles, and of those 8, 6 are shaded, so this is 6/8. Now to figure out which of these fractions are equal, we're going to want to simplify all of the fractions as much as we can. If we simplify 2/4, we know that 2 goes into 4 2 times, so we're going to divide the top and the bottom both by 2, and we'll get 1/2. For 3/8, we can't simplify that at all. There's nothing that goes into both 3 and 8. There's again nothing that goes into both 3 and 4, so we can't simplify R. 6 and 8, both 6 and 8 are divisible by 2. So we're going to divide both the top and the bottom by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So this fraction is equal to 3/4. So if we look now, Our fractions in fully simplified form are 2/4, 3/8, 3/4, and 3/4. The two that are equal are R and S because they're both 3/4. That means our answer is going to be D, R, and S. A farmer has 348 apples and wants to put them into baskets. He will put 6 apples into each basket. How many baskets will the farmer use? Okay, so since we're trying to split the apples up into groups of 6, we're going to want to do division. So we do 6 into 348. Six goes into 34 5 times. 5 times 6 is 30. 34 minus 30 is 4. Bring down this 8. 6 goes into 48 8 times. 8 times 6 is, 48. Subtract that and we get 0. So 6 goes into 348 58 times. So our answer is C, 58. Maria is making a snack mix. For the recipe, she needs 2/4 of a cup peanuts, 1/4 cup raisins, and 2/4 cup chocolate chips. Maria will double the recipe. What is the total amount of peanuts, raisins, and chocolate chips she will need? Okay, so for the original recipe, she needs 2/4 peanuts plus 1/4 raisins plus 2/4 chocolate chips. And altogether, that's going to add up to 5/4. Now, she wants to double the recipe. So to figure out how much she's going to need to double the recipe, we need to do 5/4 times 2. And when we do times 2, we can make that times 2 over 1. 5 times 2 is 10. 4 times 1 is 4. So we get 10/4. And if we look over here, that's equal to solution D, 10/4. And that ends the calculator inactive section. I'll make a separate video for the calculator active section. Thank you for watching along, and I hope this was helpful.